Today we will be covering object pooling using generics. Object pooling by itself isn't a very advanced topic. Unity, in fact, has an official tutorial for beginners that covers object pooling, but the way we'll be handling it today is using some advanced C# programming features and just creating it in an all-around extensible way that isn't actually limited to the Unity engine. So to start out, this is basically an empty project. I just created a couple of folders. Inside the scripts folder, we're going to have a couple things we're going to use to test the object pooling that we create, and one of them will be like an object launcher. So let's just call it object launcher. Just think of it as like a cannon that we'll use to shoot objects, and it will have a method on it that we will call and pass objects into, and it will just shoot them out. We're also going to have an object feeder to accompany that, so object feeder, which will just send a message and an accompanying game object to any object you desire. So it won't just be limited to the object launcher object. It will be, you can use it for any context. We will need one other thing, but we'll create it later. In the abstracts, let's go ahead and create actually, let's open up Visual Studio. So let's double click on Object Launcher here. And it opened over here. Let's open up the assets folder. Alright, and make sure that you show all files, because unless you have an existing script in a folder, it won't appear in the solution. And right click on it and hit include in project on both of them. Alright, now you can unhide all files. And on the abstracts, right click, create new item. Go ahead and hit interface, and we'll call this iPool if our keyboard is in Dvorak mode. There we go. Alright. And let's change the namespace to, I guess you could do your last name and then dot pooling. Alright. And be sure to make it public. I'm still not sure what the purpose of a private interface is, but and now hop over to Concretes and create a class that we will have, say, let's make it a queue pool. So internally it will act like a queue, and it will be an object pool at the same time. Also, if you don't know what an object pool is basically a way of reusing objects that you create without destroying and reinstantiating them. So, for example, if you have a character that is firing bullets, then instead of the bullets being destroyed upon hitting something or having to create a new bullet each time, it will reuse an older bullet that will just deactivate in between. Deactivate or some other thing. Namespace spec.pooling. Alright. And let's remove these useless using statements. Alright. And hop into iPool. And it's only going to have one method on it. And we need to make sure that this is generic, so we'll add a t parameter. And it will be a method that returns the type that the pool is created. So it will be a t get instance, and it will just return an instance from the pool. Do not confuse this with the singleton. Singletons are for simpletons. Do not use singletons. So it's just an action that will return an instance from the pool. Go ahead and save it. Hop over to the queue pool. Make sure it implements the iPool interface with the t parameter. T, not tree editor. Need to make sure that this also has a t there. And make the class public. So we need to make sure that it implements the iPools method that is getInstance. So public t getInstance. And now we have stuff in here. Stuff goes in here. Stuff. Alright. But we also need a constructor. So public queuePool t. And the way we're going to create this pool is we're going to pass in a factory method, or just a function that produces something to be added to the pool. And that's going to take the form of a system.action. So above, let's just add using system. If you're not familiar with action, it is a delegate that returns void and can optionally have parameters, but we're not going to be having any parameters. So this is action. Oh wait, no, it's going to be a func, excuse me. It's going to be a func that returns type t. So this factory method will return an instance of the class that it will then use for the pool itself. And we'll call this factory method. Alright. And we also want an integer containing the maximum capacity for the pool, or the initial maximum capacity. But for this implementation of the interface, we will use a fixed size thing. So it's going to be int max size. Alright. We don't need the generic parameter in the constructor argument itself. Let's hop down and close that off. There we go. So now we need some fields that we can store this in. Private fields, of course. We'll say func t produce, as that's how we will invoke it in the body of get instance, or wherever we're instantiating it. And we need an int containing capacity. Alright. Now capacity equals max size, and produce equals factory method. Excellent. Now, we could instantiate everything that we would have in the pool right here, but I kind of want to be able to instantiate it on demand so it doesn't just use all the memory up front, it does it lazily, I guess you could say. But before we do that, we need to make sure that we have a way of storing all of the objects that are in the pool, and in that case, rather than using an actual queue, we can just use an array and then have a pointer to an element in the array. So we'll just say a t objects, and then an int that corresponds to the index. And we'll start the index at -1 so that it knows that no objects are in there yet. But of course that depends on our code here. So we'll say index equals index +1, but we need to run it through the mod operator by the maximum capacity of it so that the index doesn't overextend the size of the array. Now, if this was just the normal way, we would just do return objects index, and that would be all fine and dandy. However, we need to account for objects not being created yet, and we need to be able to produce them, and you'll notice that produce is now valid. So this will return type t. But we need something to store that in. It will go into objects index. However, we only want to create a new object if there isn't already one in there. So this will be if objects index equals null. Come on, there we go. So if it's null, then we create a new one and store it in objects index. And that's pretty much it. Of course, though, we do need to make sure that we initialize the t array up here. So objects equals new t, and we need to have its size be max size. Alright. And if you wanted to from here, you could run some unit tests, but I'm relatively confident in my code. Famous last words. Go ahead and save that. And let's hop over to the scripts we're going to be using to test these in the Unity editor itself. Also, if you're unfamiliar with unit tests, you can just right-click like inside a class and then hit create unit tests. And then it automatically has some things installed that will automatically go ahead and create some tests for you that you can use to test your code. However, let's hop over to Object Launcher here, and this will just take in an object. We don't need any of the existing ones. Public void launch, and then we have a game object. I guess we could call it geo. Actually, I believe send message passes objects, so we will actually refer to it as object. Obj. And then in here, var body equals object as object as game object dot get component. You need to make sure these are in parentheses, of course. Get component rigid body, and that's because we're going to be using the rigid body and adding a force to it so that it shoots off from where the launcher is. Also, we need a public vector 3 launch vector, and this will let us just manually set how the launcher will fire objects. Also, the way that we're implementing it, it will launch the objects from its location, as if this was like a cannon and you were passing in cannonballs or something. So we're going to say body.transform.position, not body.position. I'll explain that in a bit later. Dot position equals transform.position. Body.transform.rotation equals transform.rotation. Rotation. Alright. And then we will say body.velocity equals 0, or vector3.0 rather. And this is just in case the body already has existing velocity and we want it to fire with just the velocity that we have here. And then we say body.addForce launch vector. And then we have force mode of velocity change. We could just set velocity to launch vector, but this is the more recommended way of doing that because it lets us change the force mode. We can make it acceleration or an impulse, for example. But for now, we're just sticking with change velocity. And we also need to make sure that the game object is active. So obj as game object dot set active true. Alright. I guess we could cache obj as game object, but nah, I'm too lazy. Alright. Didn't save. Alright, now let's hop over to our object feeder. And then we realize we're missing something here. We don't want to hard code this relying on the internal types. Like we went through the trouble of creating an interface. We don't want to hard code what type of pool it will be inside the object feeder itself. So we need some way of referencing it. However, this is a mono behavior, and iPool does not extend from a mono behavior. So we can't like drag and drop the object pool as if it was a component onto the object feeder. So we're going to actually need an abstraction of the iPool or a container for them that is a mono behavior. So we will say MonoPool. Alright. And in this class we will have a public int capacity, and this will be what's passed into the constructor for it. And that should be it for now. Oh, we also need to make it so that the object feeder can access the pool itself. So we will say public iPool game object pool using bec.pooling. Alright. Enter, and in start, we simply say pool equals new qpool game object, and we need to pass in a factory method. So how are we going to go about doing this? Like, what does this entail? In this case, we're just going to pass in the built-in instantiate method. Oh, we also need a prototype that we actually instantiate. Public game object prototype. Alright. So now as a lambda, we pass in instantiate prototype. Remember, this does not get executed immediately. Since we have this part at the beginning right here, it's passed in as a method call rather than actually calling the method immediately. And then we also pass in capacity. Alright. Now, after this is initialized, our object feeder should be able to access this. Also, let's make sure this is done in awake so other things can reference it in start. Now in the object feeder, we have a public MonoPool source pool. And then we need a method that we invoke repeatedly in this in order to continually feed an object into something else. And in order to do that, we'll just call this feed object. And it will simply, we need a destination, so a public game object destination. We need a string message, because we're going to be using the send message method. Public string ring send message by itself. We need a reference to the MonoPool, which we already have, and we also need the amount of time in between the invoking, as well as a delay. So public int invoke delay equals, we'll say a default of 1f, so it will pause for a second before it public float, not it. It will pause for a second before it invokes it the first time, and then public float invoke period, and this is just the delay between each invocation, and we'll say that 0.5f. Alright, and then in start, void start, we do invoke repeating feed object time, which is the delay, so invoke delay, and then invoke period. There we go. And that'll be it. And then inside feed object, we do destination dot send message, and the message will of course be message. And as an object, we will do source pool dot get instance. Also, it looked like that was actually a field. I think that was a mistake on my part. Back in MonoPool, for public iPool game object pool, we should have this as a property rather than a field. The only reason to have a public field is so that Unity can serialize it easily. But since this isn't an object that we can drag and drop in Unity, there's no reason to not have it be a property. So we'll have get and private set. So back to object feeder. Yep, that should be good. Let's clean this up because that's not the update method. And that should be it for testing for now. So we can hop into Unity. Make sure there's no errors. And there's not. So let's create an empty game object. Create empty. And we'll call this the pool. And let's duplicate it a couple of times. And rename. And we'll call this the launcher. And we also need a feeder. Alright, so let's kind of organize these. So we have the pool, to which we will attach a MonoPool. The feeder that we will attach an object feeder to. And the launcher that we will attach the object launcher to. And let's just change this launch vector immediately to like 10 and y. So it shoots the object up in the air. We also need an object that we will launch, so let's create a capsule and say this, rename it to launched object, and add a rigid body so we get a bit of physics interaction, rigid body. And now we need to assign the references from the other things. So launched object will be the prototype. Initial capacity for the MonoPool will be 10. The feeder needs a reference to the pool, so we'll drag and drop that. The destination will be the launcher. The message will be launch. And we can use the default values for invoke delay and invoke period. And let's start off the object disabled, the launched object anyways. And let's go ahead and hit play and see what happens. Place your bets on whether it'll work or not. Beautiful. You'll notice we have exactly 10 here, yet it keeps launching. So if I go right here and look at them, you can see that the oldest ones keep getting deleted and they're replaced with the newer ones. Well, they're not deleted. That's the whole point of an object pool, is they're simply moved back to the initial position and then launched upwards again, rather than being deleted and reinstantiated. So, also, if you want to confirm that it's not making new objects, you can simply select one of these. Keep an eye on it. If the object was deleted, then this would get unhighlighted, but since it stays in the same place and remains highlighted, we know that it's the same object being reused over and over again. Alright, now let's hop back into the code. You'll notice that the current implementation that we have, QPool, It's fairly primitive. Like, it's only useful for something where it would be using the same object over and over again for the same time period. Like maybe on like an assembly line or something, where you'd have objects going on a conveyor belt and then they drop off at the end, and then that object that was dropped off could be recycled and put at the start of it. However, if we're in a more advanced environment, such as maybe shooting bullets or something, where the objects can be used for a limited amount of time, we need a slightly more advanced system. So let's create a list pool. Let's see here, class. Actually, we can go ahead and copy our QPool class, since some of it will be the same. Go ahead and right-click and hit copy, then select the folder, and then hit paste. Hop into it. Change the name. We'll change this to list pool. If our keyboard is in Dvorak mode. List pool. And make sure we change the file name as well. List pool. And change the constructor. Alright, so the difference with this system is we're going to have it expandable, so that if it increases beyond its initial size, it will simply create another object. And we're also going to make it so that the person who accesses the list pool has the, or who creates the list pool rather, has the option of passing in a func that will return whether or not an object is currently being used. If you've seen the object pooling tutorial that Unity has, they simply check whether the object is active or not. However, that doesn't work if the object isn't based in Unity, if it's not a game object. So we're going to add in here a bool. Bool expandable equals true. And that's just so by default it will expand if necessary. And at the beginning, we're also going to have a func bool that also has a t as an argument in use, and this is so that it can check each instance in the pool to see if it's in use or not. And we're also going to change it from an array here to a list if we use system.collections.generic. Using system.collections.generic, list t objects. Alright, and make sure we initialize it properly here, so it's going to be new list new list t, and we want its length to be max size. Even if it's expandable, we're just going to initialize it with the initial size. And after this, we need to make sure that rather than just incrementing an index, we need to make sure that we check each element to see if it's in use, and if all the elements are in use and we're not completely through the pool, then we will create a new one. So let's see here. The first thing we need is a count of the current instances in the pool. Var count equals objects.count. And then for each var item in objects, if the item is not in use, so we will use the in use method that we need a reference to up here, func bool t, oh wait, no, it needs to be t bool, because as IntelliSense is saying, the result comes last. So func t bool use test, and we also need to make sure we change it right here, t bool, and down here we need to set it to that, so use test equals in use. Also, we don't need the index there anymore. So if not use test item, then we can just simply return item. So if the object is not in use per this use test, then we will return that item in the getInstance method. And then the caller of it will set whatever it is that makes it marked as in use. Hit and save. So then after this, we've iterated through every item that's already in the list. If we haven't found an object that works yet, then we need to check if the current length of it, so if count is greater than or equal to max size, capacity, there we go. That's what we called it. Count is greater than or equal to capacity, and expandable. Oh, we had the expandable as an argument here, but not actually in the function itself. So we will go bool expandable. And then down here we do this dot expandable equals expandable. And this is just making sure that this is literally making sure that we are referencing this expandable rather than this one. So back down here, say and it's expandable. Then we want to add a new item to the list, and we do that with the produce method. So we do var object equals produce, and then we say what was it again? Objects. There we go. Objects. Dot add object, and then we return object. Otherwise, we return null. Save it. Oh, hold the phone. I think I got this reversed. Right here, we need to check if it's greater than or equal to the capacity and not expandable. And then we will have it return null if that is the case. And then make sure we move these things out. So basically, it will return null if the object that we want will exceed the capacity and it is not expandable. Otherwise, if it is expandable, then it will continue on to this and it will actually expand it. Let's see here. Cannot convert. Alright, we also need to make sure that it inherits from a class, so we can do where t class, and that just makes sure that we have a nullable type that's passed in, so we have the ability to return null if we want, and that should do it. So, save it, and hop back into Unity. And, oh wait, we also need to make it so that the MonoPool has the ability to create a list pool rather than just a queue pool. So let's create a public enum pool type, and it can be either queue or list. And then after that, public pool type equals pool type dot, we'll start it off with the default of queue since that's the one we know it works right now. And then right here we will use a switch statement. So switch, I'm bad at keyboarding. Switch pool type, and in the case of it being a pool type dot queue, then pool will be equal to this. Then break. Also make sure this is tabbed, that bothers me. Wonderful. Alright, but in the case that it's a pool type.list, we need to do other stuff. So other stuff, and then break, and then in the case of default, just return, I guess. Nothing particularly special we have to do here. So now pool equals new list pool of type GameObject. And just like the previous one, we pass in a factory method first. So we make this instantiate prototype. For the next argument, we need a max size. That'll be the same, capacity. And then we need a func to check if it's in use or not. Now, the easiest way to do that in Unity is to check if the object is currently in use. So the way we'll do that is pass in a g through the lambda, and for the test it will be g.active in hierarchy. I think active in the hierarchy is the one you want. Either that or it's active self, but for now let's assume it's active in hierarchy. And then for expandable, we need a parameter up here, so public bool expandable equals true. And then down here, we just pass in expandable. So expandable only affects it if it's a list queue. List pool, not a list queue. What am I saying? Alright, now we can save that and hop over into Unity and test to see if it works. Again, place your bets. So let's change the mode to list. And the way to easily test it is not make it expandable. So what ends up happening is if it exceeds the count, then it will return null, and that will probably throw an exception. So let's see what happens. Seems to be working like normal. And then we want a red warning to pop up. Yep, failed to call launch function. Excellent. So that means it's working fine. Even though it's an error, it means it's working fine. Now, if we check expandable, assuming it's working properly, then we will continue to see objects created past the initial 10, rather than it throwing an error. Yep, and if we manually disable an object, then it gets used instead. So if I keep disabling an object, you see it's not creating any new ones. Instead, it's reusing this old one that I keep disabling because it's detecting that it's not actually in use. And also, if we open up the profiler, and let's change this back to a queue, so pool type queue, and again, expandable doesn't make a difference with queue, and we hit play. Let's open this up and try to find a place where some of it's being processed. Alright, let's hit pause and see if we can find it. That looks like it might be one. Scrolling through. Alright, there we go, found it. You'll notice that it's actually doing some garbage collection allocation here. And the reason for that is we hadn't actually reached the 10 objects by that point. Up here we can see where the other instances of the method being called are, and if we jump to this one, we see that it's not using any garbage collection anymore. So once it finished instantiating everything, it stopped using garbage collection. And now if we let it run and go down to memory, you can see it's not using anything really. However, if I were to create a pool that instead instantiated objects every single time, we would see something much different, and I will cut to a clip of that in a second. So I've gone ahead and created a new pool type that is called not a pool, and it basically just destroys objects and then reinstantiates them using the same logic that the cube pool did, except for it's destroying and reinstantiating rather than reusing. So, untested, let's hop into Unity and see what happens. So let's go ahead and change this type to not pool, and then hit play. It should only use 10 like before. At least it should appear to only use 10. But if I select an object, you see it start to scroll up, and then once it gets to the top, it disappears, and that means it's being deleted. Now if we scroll down to memory allocation, you see something that looks a lot different than what it looked like before. Before we just had a few peaks, and they weren't even coincident with the peaks that were from the object feeder. But now, you see where the blue highlight is right here, it lines up perfectly with the garbage collection allocation, which means bad things. So, what can this system do that the one that the Unity tutorial couldn't? Well, aside from being able to be used outside of Unity entirely, if we hop back into the code here, reload. So everything that's in these abstracts in concrete pool, except for not a pool, which is what I created just for demonstration, can be used outside of Unity as long as it supports C#. The one that the Unity tutorial had could only work with game objects. This can work with any type, including other pools. So let's hop into the MonoPool item here and make it so that we can actually drag and drop another MonoPool to be the source for where it creates the object. So rather than instantiating an object when we query an item from the pool or retrieve an item from the pool, it will actually take an item from another pool. So we'll do public MonoPool pool source. And this is going to be really dirty just to show things really fast. We're going to copy this. Copy. If pool source. And then return And then in here, rather than passing in instantiate, we do pool source dot get instance, or pool source dot pool dot get instance. Go ahead and copy that and paste in all these. Again, normally you wouldn't copy and paste stuff like this, but just to get a quick example out. Oh, accidentally deleted the lambda part at the beginning. Alright, that should work. So now we should be able to have a global pool of sorts. So let's duplicate this pool here. Control D. Alright. Make sure we set this pool back to a queue. And then we have this pool that we will make a list. And we'll give it, say, 20 elements. And then from this pool, we will actually have the pool 1 as a source. And let's rename this to global pool. Global pool. So now in pool we have global pool marked as the source. So when our feeder script asks for an object from this pool, rather than instantiating it, it will draw it from the global pool. And if the global pool doesn't have it, then it will instantiate it and further pass it down back into this pool, which will then be passed back into the launcher. So if we hit play, we should see identical behavior to before, if everything is working properly. And we see exactly 10 objects there. However, what happens if we take global pool and make global pool a size of 5 and make it not expandable? In theory, this should make it so that it throws an error as soon as it gets 5 objects out, even though the capacity for this pool is set to 10. And yep, we got an error there. Failed to call function. Alright, so everything's working as intended, and that'll be it for this tutorial. However, one more thing, if we hop back into the code, I got a challenge for you viewers. If we hop into list pool and queue pool, let's create this in a new thing. Each of these get instance methods here can actually be reduced to a single line of code. For this one, you might have to use system.link, but if you can type in the comments single line versions of both of these, so the get instance method for the queue pool and the get instance method for the list pool, the person who gets them correct first, or at least has a working version, in other words, a version where I can literally copy and paste the single line of code and replace it here, so it'd be like do stuff right here, without pasting any other methods or anything. If it works, they will get priority when determining the next subject for the next advanced tutorial. And until then, thanks for watching.